Okay, let's do some antiderivatives. So what I have here is the integral symbol. Notice I have a dx. You will never in your life have this symbol without having some kind of differential here. And that tells you what your independent variable is. In this case, it's x. Okay, the sum rule that we just did right here says I'm allowed to just do these one at a time. So we usually don't write all this out. We normally just do these, but just for clarity, I'm going to distribute my derivative. And I have to write dx on each of these. And not only can I distribute it, but these constants can come out. So I'm going to take the antiderivative one term at a time, but these constants can each come out front. So I'll have 5 times the antiderivative of x cubed dx minus 7 antiderivative of x squared dx plus 3 antiderivative of x dx. Notice I'm writing dx in every single integral plus antiderivative of 4 dx. And I could write that guy right there. I could write that as 4 antiderivative of dx. And I'm so used to this, that wouldn't bother me. That might bother you where you go, well, I don't know what I'm doing the antiderivative of. We'll get to it. I'll talk about it in a second. Right. That 5 is just going to come along for the ride. The antiderivative of x cubed. The power goes up by 1, and then we divide by the new power. Seven comes along for the ride. Antiderivative of x squared. The power is going to go up by 1, and I divide by the new power. 3 comes along for the ride. That's x to the first. The power is going to go up by 1 and divide by the new exponent. And then here, what's the antiderivative of dx? What's the antiderivative of, like the 4 comes along for the ride. What's the antiderivative of 1? It's x. You could think of this as 4x to the 0 power if you want. So the 4 is going to come along for the ride. 0 is going to go up by 1, divide by the new exponent. And then don't forget at the end, every time you're doing antiderivatives, we put a plus c. Now you might argue with me, wait a minute, why didn't you put plus c at the end of each one of these? I could have plus c, plus c, plus c, plus c, plus c. But this is an arbitrary constant. It's just some random number that I don't know yet. All that gets squished together at the very end. You don't have to write a bunch of plus c's. We squish it all together in the very end into one single plus c. Okay, let's check this. I'm done. That's the answer. That is the general antiderivative of that function. Let's check it by taking the derivative with respect to x. What do I get? I'll get 4, which will cancel that 4, times 5x to the third. The 4 came down and canceled that 4 and then went down by 1. 3 comes down. That'll cancel that 3 and then drops down by 1. The 2 will come down. Hey, it's going to cancel that 2 and then drop down by 1. What's the derivative of 4x? That's just plus 4. What's the derivative of any constant? 0. I mean, I could write plus 0, but there's no need to. Is that what I started with? Yes, it's exactly what I started with. So this is the general antiderivative of that function. Okay, this one I'm going to do much quicker. Now, it looks like we've got a quotient. So your brain probably says, oh, we got to use quotient rule. There is no quotient rule. It does not exist. There's no antiderivative quotient rule. Like I've seen it done once in my life. There's a way where you could do a form of integration by parts by using the derivatives quotient rule, but it is very complicated and would not apply here. No, what we want to do here is split this fraction up. The only rule we know right now is power rule. I'm going to have to use power rule. I'm going to write this as x squared over x plus 4 cube root of x over x dx. I have not done any calculus yet. All I did was split up a fraction. You're always allowed to split up numerators. Can't split denominators, but you can split numerators. Now let's think about this for a minute. Cube root of x could be written as x to the 1/3 power. So here, I'll write out a couple of steps. This should be easy. X squared divided by x is just x. Again, I've not done any calculus yet. This is just algebra I'm doing right here. Now think about how do you divide like bases. I've got an x to the 1, x to the 1/3. I'm going to have to subtract, right? 1/3 minus 1 would be negative 2/3. Okay, now we're just going to do the antiderivative using the antiderivative power rule. And we're going to do it one term at a time. I'm not going to write out distributing like I did up here. I'm just going to do it. The antiderivative of x, that's x to the first. His power is going to raise by 1 and divide by the new power. That 4 just comes along for the ride. This power is going to raise up by 1. So negative 2/3 plus 1, or 3/3, would be a positive 1/3, dividing by the new exponent. Don't forget the plus c at the end. So my power went up by 1, divided by the new exponent. I could clean this up a little bit. Do a little keep change flip here. Dividing by 1/3 is the same as multiplying by 3. So this would be 12x to the 1/3 power plus c. There is the general antiderivative of this function here, and we call that function the one that's inside the integrand. Okay, here, let's look at this one. Now we got to look back at our integral table that we have. If we look back at our table, that 4 can come out. Let's pull that 4 out. You may remember the guy whose derivative is 1/1 plus x squared. And by the time you get to Calc 2, you'll basically have to have that memorized. But that is here in our table. It's funny, it's not in our table. It's not in our table because our table was wrong. This is wrong. There should not be a square root on either of those. I'm going to fix this. That is not true. This is 1/1 plus x squared. And going backwards, that's not true. Arctan is the antiderivative of 1/1 plus x squared dx. The rest of these look right. Yeah, I was coming up here to look at the table and go, look, it's right there. And then it wasn't there because that was wrong. That is the derivative. What I have inside there is the derivative of inverse or arctangent. So the antiderivative of 1 over 1 plus x squared dx would be 4 arctan of x plus c. Don't forget your plus c. Okay, what about this one? This one looks like it's going to be really hard. Let's do a little bit of trig on it. What is tangent? Tangent, anytime you see tangent, first thing you should think is sine over cosine. Hey, look, one of the cosines will cancel. No calculus was done there. That's just trig. I want the antiderivative of sine. This is where you're going to mess up your pluses and minuses. The derivative of sine, regular sine, is positive cosine. The antiderivative is not regular cosine. It's negative cosine. Antiderivative of sine is negative cosine of x plus c. Okay, that's a good place to stop here.